Good morning students. In the previous video, we see how to find the adjoint of 2 by 2 and inverse of 2 by 2. Suppose adjoint is given, how to find A and A inverse. So we see all the sums. Now we move the next exercise. In this exercise, some linear equation is given. Using this linear equation to solve by a matrix inversion method. Okay, this method is called matrix inversion method. What is meant by a linear equation? A linear equation means it may be a 2 variable or a 3 variable, but there is no square root on a cube is involved. I give one example. 3x plus 4y is equal to 5. So this equation is called a linear equation. It contains just 2 variables. The variables are x and y. So one equation. And another one equation. 4x minus 3y suppose is equal to 0. So our question is, solve these two equations by using this method, matrix inversion method. In 9, 10 in the lower class, we solve these two equations by either elimination method or cross multiplication method. Our motto is to find the value of x and y. But here we solve these two equations by a matrix inversion method. So this equation is called a linear equation. Now we solve these two equations by the method of matrix inversion method. So the first step, suppose the 2 by 2, the same equation is given. Our question is, solve these two equations by matrix inversion method. How to solve? The first very important step is to convert the given two equation in a matrix equation. What is meant by a matrix equation? An equation contains all our matrix is called a matrix equation. So the first step to convert the given two system of equation converted into a matrix equation. It's a very easy one. How to convert? We see the coefficient of x and y in the first equation. What is the coefficient of x and y in the first equation? 3, 4. So we form a matrix. The first row is the first equation coefficient of x and y. So 3, 4. And you see the second equation whose coefficient of x and y is 4 minus 3. 4 minus 3. And the next one is the variable equation. What are the variables here? X and y. The first variable is x, so I write here x. And next one is y. Is equal to, we write the RHS values as it is. So the given system of these two equations, system means it contains two equations. We say it is a system of equations, can be written in a matrix equation. This equation is called a matrix. Now we simplify this matrix equation, this equation automatically will come. You know how to multiply two matrices, row and column is 3x plus 4y. Next 4x minus 3. So it's a form of 2 by 2 matrix. Okay. You know very well, in a matrix equation, suppose the two matrices are equal, then the corresponding elements is also equal. I clarify. Suppose we multiply these two matrices. How to write? It become 3x plus 4y. Okay. 3x plus 4y. First row, first column. Next, second row, first column. 4 into x is 4x. Minus 3 into y is minus 3y. So 4x minus 3y is equal to the RHS matrix 5, 0. Now you see these two equations are equal and also in same order. You know very well, when two equations are equal and also in same order, then the corresponding elements are equal. So what are the corresponding element? 3x plus 4y is equal to 5. Next one, 4x minus 3y is equal to 0. Again will come the given equation. So the first step in matrix inversion method, the given system of equation is converted into the matrix equation. Okay, the matrix equation is of the form this manner. And we will put the name of the matrix. Usually, the first matrix name will be taken is A. And the second one, the variables x and y occur. So we will take this matrix name is X. Is a capital letter X. Because all the matrices are denoted only by capital letters. And the RHS matrix, you should be taking it is a B. You see, which choice will be taken any letter. Maximum will be take, the first matrix is called A, and the variable matrix will be taken it is X, and the constant matrix will be taken it is B. So how to write this equation? We write this equation as A. So the first matrix is A. What is the next matrix? X. AX is equal to, or this matrix will be taken it is B. So it is the first step to convert the given system of equation as the matrix equation. Next we find the solution. So our solution is to find these values of this x and y. To find the matrix X, so we need this X only. But in X, before matrix is A. How to eliminate A? In our previous class, we see so many sums. A is there, we remove A. What is the working? So taking whose inverse on both sides. The inverse of A is A inverse. So I pre-multiply A inverse on both sides. Okay, I pre-multiply A inverse on both sides. You know very well, matrix multiplication is always associative. So we change the bracket. So it become A inverse into A into X. I change the bracket. A inverse into A into X is equal to RHS. A inverse into B. You know very well the value of A inverse and A is always I. X is equal to A inverse into B. What is the value of I into X? The value of I is an identity of unit matrix. Unit matrix is multiple with any matrix, we have the same matrix. So LHS value is just X is equal to A inverse B. So in all the case, capital letter X is equal to A inverse into B is the solution of our equation. So X is equal to RHS is A inverse into B. B matrix is, we know very well, to find A inverse. So to find A inverse in usual method, the formula to calculate A inverse is 1 by determinant A into auxiliary. So you don't use Gauss-Jordan method, just we use the formula method. So it is a solution to find the given system of equation in a matrix inversion method. Then we find A inverse and B. Capital X is always contains. There will be a small letter X and Y. Suppose for example, the capital X value is, after we find A inverse and B, that value is suppose 2, 3. What is the value of capital X? The value of a capital letter X is, capital X is small letter X and Y. Okay, now we apply this matrix value here. So capital X value is X, Y is equal to, we have the same value. You see these two matrices are equal in order. Therefore the corresponding elements are equal. So the value of X is equal to 2 and the value of Y is equal to 3. So the solution of the given sum is suppose X is equal to 2 and Y is equal to 3. Using this matrix inversion method, we solve some problems. You see in exercise 1.3, the first one, you see the question. Solve the following system of linear equations. Okay, 2 or 3 equations given, we say it is a system of linear equations. So very important, using by matrix inversion method. We must solve this equation by the method of matrix inversion. So the first step, we write the given equations. Given. What are the equations are given? There will be 2. We check coefficient of x and y term only lies in LHS and the constant term lies in RHS. Suppose one of these the constant is also lies in LHS. So first step, to write the coefficient of x and y in LHS and constant in RHS. We have both the equation, both the constant lies in RHS. So no problem, we write as it is given 2 equations, 5x, 2x plus 5y is equal to minus 2. X plus 2y is equal to minus 3. What is the first step to convert the given system of equation in matrix equation? How to convert the matrix equation? It's an easy one. We form an matrix. Actually it is a 2 by 2. So in the first row, coefficient of x and y in the first equation. What is the coefficient of x and y in the first equation? 2, 5. Okay, 2, 5. In the second row, coefficient of x and y in the second equation. Coefficient of x and y in the second equation. What is the coefficient of x? 1. And coefficient of y is 2. The next matrix is the variable matrix. Here the variable is stored from x. So I write here x. And the second one is y. So y is equal to, and the RHS is a constant matrix. Okay. So what are the constant values here? Minus 2, minus 3. So the first very important step in matrix inversion method is to convert the given system of equation in matrix equation. Now I say it is of the form Ax is equal to B. Now I say the system of this equation has Ax is equal to B. So what is the value of A? The value of A is 2, 5, 1, 2. What is the value of x? Is x, y. And what is the value of the matrix B? Is minus 2 and minus 3. So I write briefly here the value of A. Okay, first I will take the value of A. The value of A is 2, 5, 1, 2. So right here 2, 5, 1, 2. And the value of the matrix X is small letter xy. And the value of the matrix B is the RHS matrix. The RHS matrix values is minus 2, minus 3. So here what is the value of A, X and B? Next one, we write the formula. So solve means to find the unknown values of X and Y. Here Ax is equal to B. This A will be removed, so taking pre-multiply A inverse on both sides. So the solution is, so the next step I write the solution. The solution is capital letter X is equal to A inverse into B. What is the reason to write the formula here? Because we find unknown term. X is equal to A inverse B, we wanted. We already know the value of capital letter X. This one is a 1, 2 by 1 matrix XY. And the B matrix also you know it. The value of the matrix B is a minus 2, minus 3. So to find only one unknown matrix, the unknown matrix is A inverse. So that's why I write first of all the formula. So our required solution is the product of these two matrices. So we need the product of two matrices. We know the separately these two matrices. B matrices is very well. Now to find the matrix A inverse. You remind the formula of A inverse. The formula of A inverse is 1 by determinant A into adjoint. Okay, so the next step I find the determinant. Determinant A. So determinant symbol 2, 5, 1, 2. First we multiply the leading diagonal elements. So 2 to 4. Next we multiply the remaining elements with a minus. Minus 1 5 5. So the value of determinant A is minus 1. After finding determinant, next we find adjoint. It is a 2 by 2 matrix. So we use a shortcut form to find adjoint. You remember the shortcut form? The first one is we interchange the leading diagonal elements. And next one, change the sign of the remaining two elements. So next, I write adjoint of A. The first work is we interchange the leading diagonal elements. This is the value of A. We interchange these two leading diagonal elements, both are 2. So we interchange also, we get the same. Next one, the remaining two elements sign only change. So plus 5 is there, so it become minus 5. Plus 1 is there, it become minus 1. So A inverse formula terms all are we find. That is the determinant A in adjoint. Next, we use this two value in A inverse formula. So I write A inverse. The formula of A inverse is 1 by determinant A into adjoint A. 1 by the value of a determinant A. The value of determinant A is minus 1. So 1 by minus 1 into adjoint A. The value of adjoint A 2 minus 5 minus 1 2. 2 minus 5 minus 1 2. The value of 1 by minus 1 is minus 1 or just minus. 2 minus 5 minus 1 2. So the value of A inverse is equal to, you see the matrix outside one sign is there. In matrix, anyone know the sign or scalar or constant lies outside. This one is multiply each and every element. So now I multiply this minus in each and every element. So the plus 2 become, I multiply minus inside, so it become minus 2. Minus into minus is plus 5. Minus into minus 1 plus 1. Minus into 2 is minus 2. So I find A inverse. Now the next step, to use these values of A inverse in our given solution. Our solution is x is equal to A inverse into B. So we find A inverse. And we know the value of B also. So the next step, to product of A inverse and B. So x is equal to A inverse into B. So is the value of A inverse. And another one is the value of B. Now we multiply these two matrices. Using the same way, I will take first row and first column. Minus 2 into minus 2 is plus 4. Next, we move in the element. 5 into minus 3 is minus 15. So first row, first column row. Next, second row, first column. 1 into minus 2, minus 2. Minus 2 into minus 3, both are minus. Minus and minus is plus, 2 3s are 6. So x, okay, LHS is x is equal to 4 minus 15 is minus 11. Minus 2 plus 6 is plus 4. Actually the value of capital X is the matrix, okay, 2 by 1 matrix. It contains elements small letter x and y. So the next step we use the value of capital letter X matrix, whose value is x, y, and RHS minus 11, 4. Now you see in both the matrices are equal and also in same order. What is the order? The order is 2 by 1. So when a 2 matrix both the matrices are equal, then the corresponding element is also equal. Therefore, the value of x should be is equal to minus 11. So x is equal to minus 11. And the value of y is equal to plus 4. So it is the solution of our given question. So we solve this equation by a matrix inversion method. So this method we use, suppose the question will be asked by matrix inversion method. Suppose we have a doubt in answer. Suppose the minus 11 and 4 is the correct answer or not. So we verify the given two values in the given equation. Is your choice will be take any one of the equation. Actually is the answer. The value of x is minus 11 and the value of y is plus 4. Suppose we have a doubt in the x and y value. We verify. We will take any one of the equation to the given equation. I will take the first equation of this two. The first equation is 2x plus 5y is equal to minus 2. So in this equation we apply our values of x and y. Suppose this x and y satisfies this equation, our answer is correct. Okay. X, the value of x is minus 11. Y, the value of y is 4. So 2x, 2 into minus 11. The value of x is minus 11. Plus 5y, 5, the value of y is 4. Plus 5 into 4 is equal to minus 2. 2 into minus 11, minus 22. Plus 5 4s are 20 is equal to minus 2. So minus 2 is equal to minus 2. So both the LHS and RHS both are equal. Therefore, our answer is correct. So we verify the given system of equations. Suppose we have a doubt in the solution. Our answer is correct or not, we check. But the verification is no need. Answer is enough. The value of x is minus 11 and the value of y is equal to 4. Okay, in matrix inversion method, we already see the two equations given. Now we see there will be a 3 equations and 3 unknowns. First, the fourth solution. 3 equations and 3 unknowns are given. To solve this equation by same matrix inversion method. So in this equation you see the constant is also lies in LHS. 2 constant lies in LHS and 1 constant lies in RHS. So very important, the first we write the coefficient of x, y, z term only lies in LHS and all the constant in RHS. So I write the first equation as x plus y plus z. So minus 2 becomes that side plus 2. Next in second equation 6x minus 4y plus 5z. The minus 31 becomes that side plus 31. And the third one 5x plus 2y plus 2z is equal to 30. Third equation no problem. Already the constant lies in RHS. So the first step we write the coefficient of x, y, z term in LHS and all the constant in RHS. The next step to convert the system of equation in matrix form. How to write? Is a 3 by 3 matrix because it contains 3 unknowns. The first step we write the coefficient of x, y and z term in the first equation. We write in first row. What is the coefficient of x, y, z in the first equation? Along 1, 1, 1, 1. Okay. Next is second row. The coefficient of x, y, z lies in the second equation. The second equation coefficient of x and y 6 minus 4 5. Third row. The coefficient of x, y, z lies in the third equation 5 2 2. So one matrix. What is the next matrix? The next matrix is the unknown values x, y, z is equal to the RHS is the constant matrix 2 31 30 2 31 30. So the first step to convert the given system of equation as the matrix equation. Suppose we have a doubt I write correctly or not. We check any one of the equation. I will take the third equation. I will take the third row and first column. So how to write? 5x is there, 5x. Plus 2 into y, 2y. Plus 2 into z, 2z is equal to 30. Now it is on the form ax is equal to b. Now this equation is on the form ax is equal to b. So what is the value of the matrix A? So it is a value of the matrix A. And this one is the matrix X and RHS is the matrix B. For convenience, I again write here the matrix A. The matrix A value is 1, 1, 1. 6 minus 4, 5. 5, 2, 2. And the matrix X. The matrix X value is X, Y, Z. X, Y, Z. And the matrix B. Okay, the matrix B is the RHS matrix. The values are 2, 31 and 30. So it is all from AX equal to B and it is the values of AX and B. The next step we write the formula. Okay, the solution is actually X because this matrix X contains unknown value X, Y, Z. So X only alone we need, but this X is multiple with A. How to remove A? Pre-multiply A inverse on both sides. Therefore the solution is X is equal to A inverse into B. What is the purpose to write the formula? Because we need how many matrices. Here in solution, needed matrices are A inverse and B. We know very well the matrix B. So the next to find the matrix of E inverse, A inverse. If you need A inverse to find first of all, whose determinant? Because the formula of A inverse, 1 by determinant A into adjoint. So the next step to find the determinant of A. So determinant symbol. The value of A. First row 1, 1, 1. So 1, 1, 1. Second row 6 minus 4, 5. Third row 5, 2, 2. Now we simplify this determinant. The rule is first one number symbol is always plus. So and also 1 here. So plus 1 of. We leave the number 1 occurring row and column. So we leave the first row and first column. We multiply these two. Minus 4 into 2 minus 8. We multiply these two elements with a minus. 2 5s are 10. We put one minus. So minus 10. Next. The symbol of the second number is always minus. And also the number here 1. So minus 1 of. We leave the number 1 occurring a row and column. So we leave the first row and second column. We multiply these two. 6 2s are 12. Then we multiply these two elements with a minus sign. So minus 5 5s are 25. Next. The symbol of the number 1 is a plus. So I put plus 1 of. Okay, plus this 1 of. We leave the first row and third column. We multiply these two elements first of all. 6 into 2. 6 2s are 12. Next, we multiply these two elements with a minus sign. Already one minus is there, so minus in the minus is plus 5 4s are 20. Plus 20. So 1 into minus 8 minus 10 minus 18. Minus 1 into minus 13. Okay, 12 minus 25 minus 13. Plus 1 into 12 plus 20 is 32. Is 1 into minus 18. Minus 18. Minus into minus is plus 13. And plus 32. So the simplification is our choice. So I add first of all these two positive number. Minus 18. 32 plus 13 is 45. Determinant A value is 45. We subtract 18. 15 minus 8 is 7. 3 minus 1 is 2. It's 27. Is plus 27 or minus 27? Is plus 27 because the big number symbol is plus 27. So the value of the determinant is 27. Next we find adjoint of the given matrix A. If you need adjoint, first we find, you remind, in 3 by 3 the formula to calculate adjoint A is cofactor of A transpose. The next step is to find cofactor of the matrix A. For our convenience, I again write the matrix A. So to find the cofactor of each and every element. So first, cofactor of the first element is 1. You know the symbol 1 of first value is always plus. So plus of. We leave the number 1 occurring a row and column. We multiply the remaining values. So minus 4 into 2 is minus 8. Okay, then we multiply this two element with a minus 10. 2 5 are 10. What is the final value? Outside is plus, inside is minus 18. So plus and minus is minus. So minus 18. Next one is a cofactor of the next element is also 1. The symbol of the number 1 is, you know, the cofactor symbol start from plus and the sign will go alternate. Plus minus is going on. Plus the next one is minus. So we leave the number 1 occur row and column. So we leave the first row and second column. We multiply these two elements. 6 2s are 12. Next we multiply these two elements. Okay, we leave this column and this row. 6 2s are 12. Then we multiply these two elements with a minus sign. So minus 5 i's are 25. What is the final answer? 12 minus 25 is minus 13. Outside also one minus. So minus to minus is plus 13. Next one. Cofactor of the third element is also 1. The symbol of the number 1 is plus. Okay, plus of. We leave the first row and third column because the number occur 1 in first row and third column. Then we multiply these two elements. So 6 2s are 12. We multiply these two elements with a minus sign. Already one minus, so minus to minus is plus. 5 4s are 20. Outside is plus. Inside is 12 plus 20. 12 plus 20 is 32. Next. Cofactor of. After 1 the next element is 6. The symbol of the number 6 is minus. We leave the row and column occurring the number 6. So 6 occur in the first column, second. We leave the first column and second column. We multiply these elements. Okay. So 1 2s are 2. We leave this column and this row. 1 2s are 2. Next we multiply these two elements with a minus sign. So minus 2. So final is 0. Okay, because the number 6 occur first column in this row. So the number value is 0. Next one. Cofactor of the next element is minus 4. The symbol of the number minus 4 is plus. The symbol of the number minus 4 is plus. We leave the number minus 4 row and column. So we leave the second column and the second row. First we multiply the leading diagonal elements. So 1 2s are 2. Next we multiply these two elements with a minus sign. So minus 5. Okay, 2 minus 5. Outside is plus. Inside is 2 minus 5. 2 minus 5 is minus 3. Outside is plus. So plus into minus 3 is minus 3. Next. Cofactor of the next element is 5. The symbol of the number 5 is minus. So we leave the row and column occurring the number 5. So we leave this column and this row. We multiply this two elements first of all. 1 2s are 2. We leave the number 5 occurring column and row. So we leave this row and this column. 1 2s are 2. Next we multiply this two element with a minus sign. So minus 5. What is our final answer? 2 minus 5 is minus 3. but outside also 1 minus. So minus into minus is a plus 3. So 5 over. Next, to find the cofactor of this 5. The symbol of the number 5 is a plus. Okay, the symbol of the number 5 is a plus. We leave this column and this row. We multiply these two elements. So 1 5 are 5. Then we multiply these two elements with a minus sign. So plus 4. So final answer is 9. Next, cofactor of the next element is 2. The symbol of the number 2 is a minus, so I put minus. So now we leave this column and this row. Okay, this column and this row. 1 5 are 5. Next we multiply this two element with a minus sign, so minus 6. What is the final answer? 5 minus 6 is minus 1. Outside also 1 minus, so minus into minus is a plus. So the answer is a plus 1. Next, cofactor of the last element is 2. The symbol is plus. We leave the number 2 occurring row and column. So we leave this row and this column. 1 into minus 4. Minus 4. 6 into 1 is 6, but we put 1 minus. So minus 6. So the final answer is minus 10. So we find all cofactor values. So we write it is cofactor of A. How to write the cofactor of A? So the first one value is A11 and it is A12, A13 is going on. So the first three values lies in the first row. So minus 18, 13, 32, first row. And these three elements lies in the second row. 0, minus 3, plus 3. And the third row, 9, 1, minus 10. So it is a value of cofactor of the given matrix A. Next we write the formula of adjoint. Actually the formula of adjoint is cofactor of A whose transpose. So transpose of this matrix is nothing but adjoint. So adjoint A is, I directly transpose to cofactor. Transpose, the row become a column. So the first row become a first column, so minus 18, 13, 32. So the first row become first column. And the second row become second column, 0, minus 13, sorry minus 3, plus 3. Next, third row become third column, 9, 1, minus 10. So now we find a determinant and adjoint. Next we use these two values in A inverse. Therefore, A inverse is equal to 1 by determinant A value is 27. We already find the value of determinant A is 27. 1 by 27 into adjoint. The value of adjoint A is minus 18, 0, 9. First row, second row, 13, minus 3, 1, and the third row, 32, 3, minus 10. So is the value of A inverse. Now we use this value in the solution. What is our solution? Therefore, the value of x is equal to A inverse into B. The value of A inverse 1 by 27. Okay, 1 by 27 of minus 18, 0, 9, 13, minus 3, 1, 32, 3, minus 10. Next, we use the value of the matrix B. Then we multiply these two matrices, we have the solution. Next, we substitute the value of A inverse and B in the solution. Okay, the solution is actually x is equal to A inverse into B. So the value of A inverse 1 by determinant A into adjacent. So 1 by determinant A value is 27 and it is the value of adjacent. And next B is the given matrix. Now we multiply these two matrices. The multiplication of these two matrices is always possible because the order of the matrix is 3 by 3. The order of this matrix is 3 by 1. Okay, 3 by 3. And this order is 3 by 1. These two are same, so product is possible. Our resulting order is will come 3 by 1. 3 by 1 means it has a 3 row and 1 column. So we keep 1 by 27 outside. So you don't multiply 1 by 27 inside because we multiply 27 is inside, some fraction will occur. So the simplification of fraction is more complicated. So we keep outside the constant, we multiply these two matrix, then we multiply 1 by 27. So first row and first column, first of all will be take. Minus 18 into 2 is minus 36 plus 0 to 31 is 0. Next we multiply these two elements, both are plus, so plus 9 37. 9 3 7, 27 7, remainder 2. 9 1s are 9, 9 plus 2 is 11. So first row, first column over. The next step, second row, first column. 32, 32s are 26. We move in the element, minus 3 into 31. Plus into minus is minus 3 31s is 93. For the plus, so I put plus 1 30s are 30. Next step, you will take third row and first column. 32 2, 32 2s are 64 plus, both are plus 3 31s are 93. Next, minus into plus is minus 10 30s are 130 minus 130. 1 by 27 half, we leave 0. 117 minus 36. So 117 36. 117 36. 7 minus 6 is 1. 11 minus 3 is 8. Is plus 81. Now this 2. 26 plus 13. 26 plus 13 is 39. And 93. 93. 39. 13 minus 9 is 4. Will be take one borrow. So 8 minus 3 is 5. Is plus 54 or minus 54? You see the bigger number is minus. So minus 54. Next, there will be two positive number. First we have this two positive number. Okay, we have this two positive number. We get 93 plus 64. 93 plus 64. 7, 5. Okay, 15. It's a 157. 3 plus 4, 7. 9 plus 6, 15. And 130. 7 is 2. It's a plus 27 or minus 27. So big number is a plus, so plus 27. You see, the matrix values all are having in the 27th table is possible. You know very well, a matrix outside any one of the constant is there, that value is multiplied each and every elements. So the next step I multiply 1 by 27 inside. So it become, so LHS is capital X, RHS 81 by 27. First one 81 by 27. And second one will become minus 54 by 27. Minus 54 by 27. And the third one is 27 by 27. The next step I use the value of the matrix X. the value of the matrix X is a 3 by 1 matrix. This value is X, Y, Z is equal to, in 27th table 81 is exactly 3 times. 3 27s are 81. In 27th table directly I cancel, 54 is twice, but minus sign is there, so minus 2. 27 by 27, so I cancel is a 1 time. Now you see in both the LHS and RHS, both are in the same order and also both the matrices are equal. Then the corresponding elements are also equal. Therefore, what is the value of X? The value of X is equal to 3. The value of Y is equal to minus 2. The value of Z is equal to 1. So it is our required solution. So in this solution also, suppose we have a doubt, we will be take any one of the 3 equations. Is our choice. We will take any one of the 3 equations to substitute these values of X, Y and Z. Suppose the given equation is satisfied, so our answer is correct. So now in this video, we see how to find the matrix inversion method. Suppose the 2 equations are 3 equations. What is the first step? To convert the given equation in matrix equation. It is of the form Ax is equal to B. The next one, the solution. The solution is X is equal to A inverse into B. The next step, to find A inverse and the product of A inverse and B. Then we get some answers. So it is a required solution. So I put 2 by 2 and 3 by 3 matrices. The same model sum in lies, exercise and example also we must try in our classroom.